Hello everyone, and welcome to week 6 of Abarso's 10th grade math Google Classroom. This week we will be reviewing how to solve quadratic functions by both factoring and by using the quadratic formula. These skills are directly related to several competencies, including solving quadratic models, factoring polynomials, and performing arithmetic operations with polynomials. All of these skills will be assessed on the placement assessment you take upon returning to school. As you follow along, take notes on the examples and definitions that are provided. These will be useful guides and can be used on the short quiz associated with this week's lesson. If you don't have them with you already, pause the video and grab your pen and notebook before we get started. Let's start with the do now. I want you to factor the following trinomial expression into its binomial factors: x squared minus 14x minus 32. Pause the video now and give it a try. Right, hopefully that was mental math for you. The two binomial factors of the trinomial are the quantity x minus 16 and the quantity x plus 2. If you had any difficulty solving this problem, please consult the videos from weeks 1 and 2 for more in-depth explanations on how to factor effectively. Since quadratic functions and the relationships they represent are critically important to several mathematical and scientific phenomena, understanding how to solve them is vital. If you were able to successfully answer the do now, you're already well on your way to solving quadratics via factoring. While we will devote time today to solving quadratics by factoring, most of the relationships modeled by quadratic functions require more complex procedures to reach a solution. Nevertheless, let's begin with the basics before we move on to more advanced methods. You've already factored quadratic expressions. That's what we did in the do now. The new thing here is that the quadratic expression is part of an equation, and you're told to solve for the values of the variable that make the equation true. Here's how it works. Take the trinomial x squared minus 7x plus 12 equals 0. When we factor the trinomial into its binomial factors, we get the quantity x minus 3 times the quantity x minus 4 equal to 0. Now the question is, how do I use this factorization to solve the equation? To solve quadratics by factoring, we use something called the zero product property. This property says that something that seems fairly obvious, but only after it's been pointed out to us. Namely, the zero product property states that if we multiply two or more things together, and the result is equal to 0, then we know that at least one of those things that we multiplied must have also been equal to 0. Put another way, the only way for us to get 0 when we multiply two or more factors together is for one of the factors to be 0. So if we multiply two or more factors and get to 0, then we know that at least one of the factors was itself equal to 0. In particular, we can set each of the factors equal to 0 and solve the resulting equation for one solution of the original equation. We can only draw the helpful conclusion about the factors, namely that one of those factors must have been equal to 0, so that we can set the factors equal to 0. If the product itself equals 0, if the product of factors is equal to anything non-zero, then we cannot make any claim about the values of the factors. Therefore, when solving quadratic equations by factoring, we must always have the equation in the form the quadratic expression equal to 0 before we make any attempt to solve the quadratic equation by factoring. If you need more review, we covered this property when we studied the factor theorem in week 1. Let's return back to our factorization of the quantity x minus 3 times the quantity x minus 4 equal to 0. The zero product property tells us that at least one of the factors must be equal to 0. Since at least one of the factors must be 0, then we can set each of the factors equal to 0. X minus 3 equal to 0 or x minus 4 equal to 0. This gives me a simple linear equations, and they're quite easy to solve for. Solving for x in both situations, we get x equal to 3 or x equal to 4. And these two values are the solution to the quadratic function that we are looking for. While often the simplest way to solve a quadratic function in the form ax squared plus bx plus c equals 0 is to resort to factoring, sometimes the function is too complex or cannot be factored. In these situations, we can always apply the quadratic formula to find the solution. The quadratic formula uses the a, b, and c from the ax squared plus bx plus c form, where a, b, and c are just the coefficients of the quadratic equation. The quadratic formula states that for ax squared plus bx plus c equal to 0, the values of x, which are the solutions of the equation, are found by the following. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. While the quadratic formula might look intimidating with the radical and the plus or minus sign, if you organize your work and identify each of your variables before trying to apply it, finding your two solutions is quite easy. Let's try an example to demonstrate. Let's take the equation x squared minus 4x minus 8 equal to 0. First, let's identify our a, b, and c values. As this equation is already set to 0 and in descending order according to the variable x, this step is quite easy. A is equal to 1, b is equal to negative 4, and c is equal to negative 8. Plugging these values into our quadratic formula, we get the negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 8, all divided by 2 times 1. Now it's just a matter of performing the arithmetic to find our final two solutions, which equal 2 plus or minus 2 square roots of 3. Let's try one more example together. Just like we did before, it's a good strategy to identify your variables before plugging them into the quadratic formula. So for this example, we get a equal to 2, b equal to negative 4, and c equal to negative 3. Substituting these values into the quadratic formula and performing the necessary arithmetic, we get our two solutions. 2 plus or minus the square root of 10 divided by 2. Don't worry about leaving your final solutions with radicals in the numerators. In fact, this is preferable because your answer will be exact. While the quadratic formula can be tedious, the more effort you put into organizing your work, the easier time you'll have. The following tips should help you tackle these problems with ease. Number 1. Take care not to omit the plus or minus sign in front of the radical. 2. Don't draw the fraction line as being only under the square root, because it's under the initial negative b part as well. Don't forget the denominator of the formula is 2a, not just 2. That is, when the leading term is something like 5x squared, you will need to remember to put the value a equals 5 in the denominator. And finally, use parentheses around the coefficients when you're first plugging them into the formula, especially when any of those coefficients is negative, so you don't lose any minus signs when you perform your arithmetic. Right, now that we've had some practice together, and now that you know some tips for making these problems easier, it's your turn to try some on your own. Pause the video and try the following problems. Thank you for tuning in. Hopefully you were able to follow along and understand how to solve quadratic functions. Check out the links in the description below for further resources to help you master this topic. All of these resources can be used to help you complete the short quiz associated with this week's lesson. If you have any questions or concerns, feel free to reach out via comments in our Google Classroom or via email. We're always here to help.